Hi students, welcome again. In continuation with our series of electrostatics lectures, this is a new lecture. What we are going to discuss in this lecture? Number one, we are starting with the application of Gauss theorem. I will try to put a light on the importance of Gauss theorem also, and we will also discuss why the Gaussian surface are cylindrical for the infinite line charge. So let us start. To start with, I have taken one application that is very important from the board examination point of view. Also, we have to calculate the electric field due to infinite charge wire. Student, I have written here three important points which I feel that they are very important points whenever you are solving the Gauss when any problem using the Gauss theorem, right? Be it a numerical, be it a derivation, be it any other kind of problem, right? So this is a long charge wire, right? It is infinitely charged, uniformly charged. Let us consider the linear charge density is lambda. Lambda is the linear charge density. We have to find electric field due to this infinite line charge at perpendicular distance r. So I have constructed a Gaussian surface in the form of a cylinder. This cylinder has a radius r, length l, right? Like this you can consider like this is a cylinder, right? This is enclosing a part of the wire, not the full wire. Full wire has infinite length. I have enclosed only a part, that is the L length of the wire in this cylinder. So this cylinder also has a length L and the radius r. This cylinder will be having the three surfaces, one flat, other flat, and the third one is curved surface. So let us draw the area vector. So this is flat surface, this has area vector normally outward. This is again a flat surface, area vector normally outward. This is a curved surface. Wherever I want to draw the area vector, it will be like this, like this. From our previous discussion, we know that due to the positive charge, electric field is outward. So this is the positive charge. If I check the electric field, this direction is slightly like this. If I check the electric field here, direction is like this. Here direction is like this. Electric field is like this, right? So we have constructed a Gaussian surface. We have considered the area vectors. Now we will calculate the electric flux. Before calculation of electric flux, we will discuss why we have taken a cylindrical surface. Let us do a slight discussion on that topic. We have a infinite charge wire. This is a long charge wire, infinite length. If I take a point here and I just want to know what will be the direction of electric field at this point, what I am going to do is I will take this element, and draw the electric field. This is according to our previous knowledge of electric field, that a positive charge create electric field in the outward direction. So if I resolve this electric field in the components, net electric field will be in this direction because these components will cancel out. So at this point, electric field is pointing outward and in this direction. Since it is an infinite wire, I can take this point anywhere. I can shift this point anywhere, to the left or to the right. If I shift this point to the left, same here, if I take this element, I will get the electric field like this. If I take the point here, I will get the electric field this. Now join all these points, you will get a surface like this. Similarly, if I consider these points on the other side of the wire, 1, 2, 3, I will get a surface like this. So there are two surfaces. I have to close this surface. So this is the best way to close this surface. So this is an explanation why we have considered a cylinder as a Gaussian surface for the infinite line charge. Here we will also try to understand what is the importance of the Gauss theorem. First, importance of Gauss theorem is, this theorem helps us to calculate electric field due to complex charge configurations in a simplified way. If we have a complex charge configuration like this infinite line charge, and if I want to calculate the electric field by any other method, not by the Gauss theorem, say by Coulomb's law, right, it will involve a lot of integration, lot of calculus, and the problem will be highly let us say it require a lot of time to solve that problem. So to simplify these kind of problems, we are taking the help of Gauss theorem. So Gauss theorem help us to calculate electric field due to complicated charge configuration in the simplified way, right? So now we will calculate the electric flux here. Let us calculate the electric flux. We can write down total flux. Flux total is flux flat plus flux curve. See here the flat surface, this angle is 90 degree. So flux through the flat is Es cos 90, 0. Flux through the curved surface is, that is Es cos 0. See here, this electric field and area vector, they are in the same direction. On the other side also they are in the same direction. Angle is 0 degree. Curved surface has area 2 pi RL. So this is the flux through the curved surface. So total flux is this I put here, and flux flat is 0. So total flux is E into 2 pi RL. Last step, we have to apply the Gauss theorem. So Gauss theorem is E ds is Q net by epsilon naught. This represents the total flux which we have already calculated. E into 2 pi RL is Q net by epsilon naught. Now see here, we have to calculate the net charge. Which net charge? That is inside the Gaussian surface. Here our Gaussian surface is this cylinder. We are not interested in the total charge. We are interested only in the charge lying inside the Gaussian surface. So if this wire has a charge density lambda, then I can write down Q net will be lambda into L. Right, this is linear charge density multiplied by length, which I want to calculate. So E into 2 pi RL, this is lambda L by epsilon naught. So final answer is E equal to lambda by 2 pi epsilon naught R. This is the result which is due to infinite line charge electric field. There are 3-4 simple steps. Just construct an Gaussian surface, calculate the flux, apply the Gauss theorem, right? Last point, draw a graph between E and R. Draw a graph between E and R. If I draw a graph, let us say on the y-axis I have taken E, on the x-axis R. The graph is hyperbola because E is inversely proportional to R, right? Same way in the coming videos we will be discussing the more applications of Gauss theorem. Till then, goodbye, bye bye.